Right, so this is 6.1b, and we're talking about arc length, sector area, and circular motion. Okay, so we're continuing with the circles. So first, let's talk about arc length and sector area. So imagine you have a circle like so, and that's a radius, right? So, if you put the radius on the circle, you get, it forms that angle, and that angle is 1 radian. Well, the distance on the circle where you um, put the radius, that is the arc length, and so the arc length is 1 radius. So you remember when we talked about this, right? Where the angle is 1 radian, the arc length is 1 radius. And you put another one. Now the angle is now 2 radians, and now your arc length is 2 radii, right? 2 radiuses. Same thing again, you put another one, 3 radians, angle is 3 radians, arc length is 3 radii. Okay, so imagine if your radius is like 5 centimeter. You have 3 radius, now you have 3 times 5, that's 15. So the arc length, okay, is just you take the angle. The angle is telling you how many radius there are multiplied by the length of the radius. So in this case, your angle is 3 radians. Take 3 times 5 gives you 15. That gives you the arc length. Okay, arc length is the distance on the circle. All right. Another way to get the arc length is to go from the circumference, right? The circumference, remember, all around the circle is 2 pi r, right? Because the whole circle is 2 pi. If you think about the arc length as a portion of the circle, right, you take 2 pi r, that's the circumference. You multiply by the portion of the circle the arc length is, right? Whatever the arc length is, there's an angle, and that angle is pi. I'm sorry, not pi, theta. So theta out of 2 pi, this is the yellow part here. This is basically saying the portion of the circle. If you have like, you know, 1 radian, it's 1 radian out of 2 pi, 1 out of 2 pi. It takes 2 pi to get all the way around, you have 1, or whatever theta is. Okay, so theta out of 2 pi is just a fraction of the circle that we're talking about. All right, so if you do that, you multiply by the fraction, you get the arc length. And then you cancel out the 2, cancel out the pi, it's just r times theta. So arc length is, again, theta r. Okay, so let's use an example here. They want you to find the arc length of ABC. Okay, and they give you the angle of 130 here. ABC is not from A to C, it's A to B to C, so it's actually going this way. All right, so you got to go around from A to B to C. It's the big angle, not the little angle. So we're talking about theta. We have to figure out what is theta first, because arc length requires you to know what theta is. So theta is 360 minus 130 gives you 230. And I'm going to convert that into radian because the formula uses radian. So converting to radian, I have to multiply by pi over 180, and I have 23 pi over 18. Then I can plug that into the formula. Arc length is S equals theta R. And theta is 23 pi over 18, and then radius is 4. So I put that into the calculator, I get 16.06. All right, another example here. A circular arc of length 3 subtends a central angle of 25. Find the radius. Okay, so you know the arc length is 3, and you know the angle is 25. So you put that into the formula, right? The formula S is equal to theta R. Now, in this case, S is the arc length, which is 3, but I don't know theta, so I have to use theta. I have to find theta, which is 25 degrees, convert that into radian. So again, multiply by pi over 180. I get 5 pi over 36. Then I can put it into the formula, or find the decimal form and put it to the formula. Now, S is 3, right? Because the arc length is 3. Theta is 0.436. And now I can find the radius. And, divide that. Radius is 6.88 feet. Now we're talking about sector area. Okay, again, you have an angle in your circle. Say that angle is theta. The space that that angle takes inside that circle is called the sector area, right? That whole orange space. Remember, that is the portion of the circle, and it's just pi over 2 pi. I mean, theta over 2 pi. Whatever theta is, we don't know what theta is, right? But the whole thing is 2 pi, so it's theta out of 2 pi. So to find that area, you just take the area of a circle, you multiply by that portion. So the area of the sector, we write that as area subsector, is equal to the area of the circle multiplied by theta over 2 pi. And this is how we get the formula, right? You cancel things out. So the area, the formula comes out to be 1/2 r squared theta. And with that formula, we can find all the sector areas that we need. So find the area of the sector. Here's a circle. We have that portion. The radius is 6. The angle is 75. To find the area, well, I just got to find out 75 in radian. So there's the formula. Convert 75 to radian. I get 5 pi over 12. And put that into the formula, right? I get 1/2. Radius is 6. So I have 6 squared. And then theta is 5 pi over 12. Put all that into the calculator. You get 23.56 centimeters squared. Another example for sector area, they tell you the area of the circle is 72. And the area of the sector is what we're looking for. So we're looking for the area of the sector, but we know the angle is pi over 6. Now, if you know the whole circle and you know the angle is the portion out of the circle, right? It's a fraction of the circle. So just take pi over 6 divided by 2 pi. All right. So you know the area of the circle. The fraction of the circle is pi over 6 over 2 pi. Whatever the angle is, guys, it's out of 2 pi. That's like a fraction of the circle. Okay. So pi over 6 over 2 pi is basically pi over 6 times 1 over 2 pi. And like pi cancels out, I get 1/12. So pi over 6 is 1/12 of the circle. All right. So 1/12 of the circle, I just take 1/12 of 72. And that gives me 6" squared. Angular speed. So imagine if you have an object that moves along the circle like that, right? So however long it moves, it makes an angle. So it makes an angle. We call that angle. Let's just say that's angle theta. And the distance that it moves on the circle, we'll call that yellow arc. Theta is the angular speed. Okay, angular speed is the rate at which the angle is changing. So how fast is that angle changing, right? So it's just that theta over time. And then linear speed is the rate at which the distance traveled is changing. So how much have you changed from the beginning going on the circle to the end? That's the linear speed. Angular speed is how big this angle is changing from starting at 0, right? 0 angle, 0 degree, 0 radian, and it opens up. Now it's over here. Now it's theta. So the angle is angular speed, the change in the angle, and the change in the location, the arc length, is the linear speed. So we represent angular speed by omega. There's a symbol here. Omega is equal to theta over time. And then linear speed is just, oh, by the way, this does not depend on the radius, right? The angle doesn't matter. I mean, it doesn't care how long the radius is. Like it can be a really big circle. The angle wouldn't change. Now, linear speed, we use v for velocity, is s over t, which is just the arc length over time, just how much you've traveled. That's the arc length divided by time. And so s is, again, we know s is r times theta, right? So it can also be equal to r theta over time or r times omega. right? Because omega is theta over time, so r times omega. Yeah, all of these are the same thing, but usually we use this first part here, s over t. All right. This one does depend on the radius, because if the circle is really big, you keep the same angle, but now the distance traveled is bigger and bigger depending on the radius, right? Now, revolution per minute is the number of times an object travels around a circle. Revolution. One revolution means you go around with the circle one time. And remember, the whole circle is 2 pi. So 2 pi per minute is one revolution per minute. Here is a problem. A ceiling fan with blades 18-inch rotates at 45 RPM, revolution per minute. A, find the angular speed omega in radians per minute. Just find the angular speed. You find out how much does it change, how much does the angle change in 1 minute. So this one doesn't matter what the radius is, right? We don't care how long the blades are. We need to know how many revolution per minute. Remember, 75 revolution per minute means how many radian per minute is it? Because each time it goes around, that's 2 pi. You go 45 times. Okay. So you take 75 times 2 pi. All right. So you start out with the RPM, 45 revolution per minute, multiplied by 2 pi per revolution. Every revolution is 2 pi. So you cancel out the revolution, you get 95 pi per minute. That's your angular speed. The linear speed is the tip of the blades, right? Like how fast is the tip of the blade moving? And that is the linear velocity, right? V is equal to r times omega. So you just take 18 times 90 pi per minute, and then you get, 1620 pi inch per minute. And then you multiply all that out, you get that, okay? Rounded. Some problems has a lot of conversion to do with it, so you have to learn how to do this. So here's an example of that. The diameter of the tires of the golf cart is 18-inch. When Miss Corzine is driving, the tires rotate at 180 RPM per minute. How fast is she going in miles per hour? So the golf cart is like, the diameter is 18, so the radius is 9, right? So you got to find out like how fast it's moving, how fast the tires are spinning. So the velocity is now the angular speed times r, right? So omega, the angular speed, is 180 revolution per minute times 2 pi. So you convert that to get omega, and you get 360 pi over minute. So 360 pi per minute. And I take that and multiply by 9-inch because that's the radius. Then I get 3,240 pi inch per minute. Then I have to convert this into miles per hour. So I convert inch to feet. Right? Every time you convert, you want to cancel out the unit that you start with and end with the new unit. So inch on top here, I have to put inch at the bottom to cancel out inch and inch. Right? Top inch cancel with bottom inch. And 1 foot on top. All right. So, and then I want to convert from feet to miles. So I put the feet at the bottom, the mile on top to cancel out the feet on top. Now I get mile. All right. But I have minute. They want hour. So I have to cancel out minute. I put minute on top. So 60 minute on top and 1 hour at the bottom. Then I just multiply across numbers on top divided by numbers at the bottom. And I get 9.64 miles per hour.